The first question that was submitted that I thought was interesting was this one: write a function that swaps the highest bits of each nibble of the byte. So in this particular case, this question is asking for an input that's exactly 1 byte, and the 8th bit and the 4th bit, we're going to swap those. So there's A and B. The rest of the bits we're going to leave as they are. Obviously, there could be a number of variants of this question that might involve, rather than an 8-bit input, a 16-bit input, a 32-bit input, and rather than swapping the 4th and 8th bits, it could be potentially some other arbitrary bits. But I thought this was a good kind of simple-ish question that you could obviously extrapolate out further. And I think this question is also interesting because oftentimes when we think about how good a solution is, we might think about it in kind of like the O of N sort of notation of how efficient is this based off of what sort of loops it might be going through. But in this case, pretty much any implementation we come up with isn't going to really involve loops. It should in theory be O of 1 regardless, a constant time implementation. But there still are ways that we can write something that involves fewer lines of code or fewer operations or more operations, or a more brute force or a more elegant solution. And hoping we can talk through a couple solutions so far, but I wanted to open it up first. Does anyone, given this prompt, have any initial thoughts? Like, what's your first reaction of what it is that we need to do at a high level? I always think it's best to, before we dive into the code, it's first like just in English words, like how is it we think we want to go about this problem?
I mean, at the high level, you basically want what the highest bits in each nibble are. You want to take those out by virtue of some mask and probably some ORing logic or something. And then once you have that, then you basically need to update, or rather reverse them through updating those set of bits.
Yeah, absolutely. So we really have only 2 steps in this question. First is, as you said, get the values, and you mentioned mask, which is a great option for getting those values. And then ultimately we need to update the original input with the appropriate switching or swaps. So let's dive into that first one now, getting the values. You mentioned using a mask. Do you want to elaborate on what do you mean by that? What would you have in mind?
I would like actually set the values as zeros for all of the bits that I'm not interested in, and set the values as 1 for the bits that I'm interested in. So in this case, it would be what it would be. So actually, my mind is kind of disoriented. So I'm trying to figure out, does 1x represent 1 bit?
Yes, sorry. So each one of these here, each one of these is a bit in that 4-byte data type. Oh, sorry, not 4-byte, single byte data type.
I'm sorry to be acting stupid. I just had food. So yeah, so I think in that case, it should be, the mask should be 0, 1, or 0, F, and then
sure. And we right now we can talk about this in terms of bits too. We don't have to, we can always figure out what it would be in hex or decimal from that. But I think what you're getting at is we would first want to do a mask with a 1 in let's say the A, so we can get just that value. And we would similarly have another mask, to get the other bit that we want. Maybe we could find some way of using a single mask to get both values at the same time, but logically, at least, we ultimately want to get both values, and we might want to have those values independent. So our mask our code might end up looking something, at least in pseudocode, we could have something like bit A, just to use the same nomenclature, equals our input ANDed with one or the other of these masks. But what we have at that point is we have what we end up having essentially from this is bit A ends up being something along the lines of, so we have the value, but we have that one bit that we wanted and we've zeroed out the rest of it, but it isn't necessarily in a useful form yet. At least potentially useful form. All we know is that this value will have some numerical value because of that bit being set, but we still need to figure out how we're going to get that bit to where it needs to go. Sorry, more people joining, hoping to allow everyone to speak. 1 second. Okay, sorry. So the next step that we would need to have is probably some sort of bit shift in order to get that bit to where it needs to go. And I think there's a couple of different ways we can think about this. And let me see if I can shift this whole thing. Definitely let me know if we're getting to a point where things are getting too small. But ultimately what we want to do is get we extracted or we isolated just the one bit we wanted. Now we need to make sure it gets to where it needs to go. And we just talked about using this mask. We could also potentially use bit shifting to isolate the same thing. So we could do something like we could also do that. We could also bit shift over to the right and then just mask against that rightmost least significant bit. So we can do a combination of masking and shifting in order to get to the bit where we want it to be. And then ultimately what we're going to need to do is swap those two locations of the bits. So if we go back to this one here on the left, we're going to want to shift that bit by 4 to the right. So let's if I can get back over there. Oh, now things are being separated. Excellent. We might say something like bit A equals, let's say bit A shifted by 4. So we want to ultimately get A to be over here rather than where it is right here. One danger of doing this shift as it is now, though, is we need to make sure that we're using an unsigned data type as our kind of temporary variables, so we don't get that sign extension we talked about on Sunday. So anyways, we've shifted the bit over to now where it finally needs to go. We would also obviously do the same thing for the other bit. We would do a mask to get bit B, and we would do an appropriate shift to place B where it ultimately needs to live. What would we do next? What would be the next step? Any thoughts? We've now isolated the bits. We put them where they need to go. How do we actually, what do we do next to get them back into the original value?
We need to OR bit A with, or we need to clear those bits first and then OR.
Yeah, so I think that's a kind of an easy mistake to be had is I think, oh, well, all we need to do is take B and then OR it with bit A and bit B. But the problem is that we're trying to swap it. We don't necessarily know from the get-go what those two values are. And if all we're doing is ORing, we won't, at least potentially not get the result that we're looking for. So as you just pointed out, we're going to need to make sure we zero out those two locations so that when we do the OR, we actually get the value that we're looking for there. So we might have something like B and equals, I think it would be 77. So this would be equivalent to 0, 1, 1, 1, 0, 1, 1, 1. So we would zero out explicitly those two fields from that input value B. We would do our ORs, and then at the end, we would return B. So we isolated the bits, we shifted the bits around, we zeroed them out from the destination, if you will, and then inserted those bits into the overall set of 8 bits, and then returned those values. So I think we've in a sense, Manish, I think we've accomplished what you kind of, at a high level, shared at the beginning. We got the values, and then we updated or replaced the original field. So I think hopefully people understand how this works, this kind of pseudocode here, but for the most part, hopefully folks followed along with how we would do that. Is there any way we could do that better? Or maybe said differently, is there any way we can do that with fewer mathematical or bit shifting operations? Anyone have any thoughts?
Glenn, are you thinking of combining all these into one? Like I can imagine creating a common bit mask and getting those 2 values.
Yeah, that's a good point. There is a potential for maybe there's a way of reducing this by 1 or 2 operations by extracting things a little bit differently. So maybe there's an opportunity for a little bit of an improvement there. But kind of thinking even more drastically different, is there any other kind of,
we can use XOR logic.
XOR
we can
logic.
use XOR logic. It's because it's going to be 88. I think we can use XOR and swap. I'm just thinking.
Sure. I'm just creating a new page here so we don't get overlapped with the previous part. Let me just write the function prototype here at the top again. Swap bits. Okay, so you said XOR logic. So you can elaborate on that. What about XORs are we going to take advantage of?
If it's if it's alternate bits, then we can swap. If it's if the 1 bit, if the A bit is 1 and if the B bit is 0, then you can use XOR to swap that bit actually. So I'm trying to think a big number how we can swap.
Yeah, no, you said something very important. Let me just repeat that for everyone in case it was kind of missed over, which is we can use XOR to essentially flip or toggle any bit that we want. So if we have some random value X, we can XOR that with, let's say, well, let's do it in bits again. And this will flip or toggle that bit in X. So if X was 10101010, XORing it with this here on the right would toggle this from a 1 to a 0. So using XOR, we can essentially specify the exact bit we want to toggle from 0 to 1 or from 1 to 0. So that's kind of one of the key powers that XOR is giving us here. And I think you said something else important as well, which is if the bits are different, then we want to toggle them. If the bits are and you didn't say this, but I think it was implied, if the bits are the same, we don't need to toggle them. Going back to our swap bits, if the bits in the 4th and the 8th position, or the 3rd and the 7th indices, depending on how you look at it, if those 2 bits are the same, then the input of this function is going to be the same as the output of this function. If they're both 1s, then we don't need to do anything. If they're both 0s, we don't need to do anything. We only need to do something if they're different values. So let's look at that a little bit in terms of what code might look like. So let's create, kind of as before, some quick temporary variables that are going to store what the actual 0 or 1 value is for those particular bits. And this was fairly similar code to what I had previously. So B left shifted by 3 and 1. So now bit A and bit B have at most a single bit set, the rightmost bit, and it's either going to be a 0 or 1 based off of whether there is a 0 or 1 in the associated positions in our original 8-bit value. And then, as we just said, we only need to do something. So we only need to do something if bit A and bit B are different. So if bit A is not equal bit B. If they're not equal, we need to do something. But if they are equal, then all we need to do is return the same B value that we got as input. And now what we need to do is figure out what it is that we're going to have inside of this if statement. So inside of this if clause, we've decided that A and B are different, and hence they need to be swapped. Because it's binary and the only value is 0 or 1, when we say swapped, all we really mean is we either toggle one and toggle the other one. And toggling both of them is equivalent to swapping them. So then we can just use our fairly basic XOR math. So B XOR with the XOR, toggle that bit in the 3rd position, and then similarly toggle the bit in the 7th index. And there we have it. We've updated B. If in the case where the 2 bits were different, we have toggled both of them. So one was 0 and then switched to 1, and the other one was 1 and switched to 0. And we've updated them in that same variable so that when we return it, it's going to return the right value. So it's not like we got rid of all of the operations as part of this. There still are several shifts, several ands and an equality check, but we've probably at least approximately halved the number of instructions that are necessary for this operation. So I think one could probably say that this is a better, or at the very least, a more elegant, but a better, faster solution. And it really revolved around that understanding that XOR allows us to toggle any bit that we want. Oh, and sorry, I was not keeping my eye on the Q&A box, Vasan. I apologize. It looks like you shared the exact same thing as what I was just talking about. So you were definitely a step ahead of me, and I should have been looking more at that side of the screen. Thank you. Although interesting enough, so this particular question, or the prompt, this was the prompt that was submitted tonight. So I wanted to keep that the same. Let me go back to the previous slide. Oops. So we can. This is the prompt that was shared. Although I think actually the official prompt that was shared had B as a pointer, and hence the input and the output. But this is effectively the same thing in that side of things. But Vasan, interesting, shared a more generic solution, which is, what if you wanted to swap any arbitrary 2 bits? In this particular example question, we're only ever swapping the bits in those 2 positions, but all of our math is essentially the same if we wanted to swap 2 other arbitrary bits. So going back over here, all we're really talking about is this number, this number, this number, and this number as kind of our variable, if you will. So it would be a fairly reasonable thing to do, or a fairly reasonable question for someone to ask as a variant of this question. I want to swap 2 arbitrary bits within a variable, and as parameters to the swap bits, I'm going to provide a int p and an int q, let's say, for the positions of where those bits are in my value. So this might be q, p and q, p and q, rather than having it hard-coded. So hopefully we can see there's some variants of this question. You could also ask a variant where it's a 32-bit field rather than a 8-bit field, and lots of other variants kind of that go hand in hand with bit manipulation questions. And next Sunday, we're actually going to be talking about a lot more bit manipulation sort of questions. So this is somewhat of a preview in that sense. But I thought this was independent enough that we could still cover it tonight without that prelude. Let's see here. Bhargavi, you say we can use bit masks F0 and 0F to swap the nibbles. Yeah, so a different question might ask you to not just swap a particular bit. It might say, okay, swap the entire nibble, like those first 4 bits, put them in the next 4 bits and vice versa, which in essence ends up being a very similar question, although you might be able to take a couple more shortcuts to solve it. And the particular suggestion here was just to use a bit mask to get the first 4 bits, use another bit mask to get the next 4 bits, and then just create a new variable that has the 2 of those things shifted and then ORed together. So if you're moving all the bits in the field, it almost becomes an easier problem to solve because you have to move and place each one of them, as opposed to this question where you're essentially supposed to leave everything the same except the 2 bits that you were supposed to swap. So yes, if the question was to swap the nibbles, then that would be a good solution. Yeah, so once again, there's a lot of different variants of this question. And as Bhargavi pointed out for us, it would behoove you to make sure that you understand exactly what the question is asking before you start implementing it. No reason to spend 20 minutes writing this code and find out that we're supposed to swap the entire nibble as opposed to just 1 bit or something else thereof. So a lot of these bit manipulation questions end up sounding very similar, and the solutions for them end up being very similar. And it's somewhat of a matter of wording for what the interviewer is trying to get you to do. Any other questions about this sort of problem?